let's look at some various kinds of equations and look at the procedures that we follow to solve each of those kinds of equations. This first equation is an example of a linear equation in one variable. It is an equation, equal sign. There's only one variable. It appears in several terms, but there's only one variable. And the exponent on the variable is 1. That's the key thing. That's what makes it a linear equation in one variable. Basically, the procedure we want to follow starts by examining the equation to see if we have any parentheses. If we do, we want to use our distributive property to remove those parentheses. So here we have a set of parentheses. Here we have a set of parentheses. So we're going to distribute the multiplication so as to remove the parentheses. 2 times x will give us 2x. 2 times minus 1 is minus 2. Minus 3 times x is minus 3x. Minus 3 times plus 1 is minus 3. After removing any parentheses that are there, the next step we want to take is to examine the expressions and see if we can simplify them. Generally, that simplification will come about through combining like terms. And certainly we have like terms we can combine in this expression. This will become 2x plus 1. And we have the x terms we can combine in this expression. X minus 3x is going to give us negative 2x. And we've simplified those expressions. That's step 2 in our procedure. Step 1, remove parentheses if the expressions contain them. Step 2, simplify the expressions by combining like terms. Step 3, let's create an equation that only has the variable in one term. Right now, the variable is here in 2 terms. And I really like to have a linear equation as I continue to solve it to only have the variable in one term. So I'm going to make this term disappear by adding 2x. That will disappear into 0, leaving us just the negative 3 term on the right-hand side. But remember, any kind of equation is a balance. If you add something to one side of the equation to accomplish some goal, making that variable term disappear in this case, you have to add the same quantity to the other side to keep your equation balanced. 2x plus 2x is 4x. So now I have my equation down to where I only have one term with the variable. And now I want to isolate that term. I'm going to start the isolation process by removing that extra constant term that's here. Notice I subtracted the 1 from both sides, again, to keep my equation balanced. And lastly, now that I've isolated the variable term, I want to produce a coefficient of positive 1 on the variable term. And that's done in this case by dividing both sides by 4. Because 4 divided by 4 gives me positive 1. I have x equals, dividing both sides by 4, again, to maintain the balance of my equation, negative 4 divided by 4 is negative 1. So the solution to this equation is giving x a value of negative 1. Remember what it means to be a solution to an equation. If we substitute negative 1 wherever it is here in x, the value of that new arithmetic expression on the left side will be the same as the value of the arithmetic expression on the right side. And that's our procedure we follow to solve a linear equation in one variable. What did we do? Got rid of the got rid of the parentheses, simplified the expressions by combining the like terms that were there, got rid of one of the variable terms, so we only had the variable in one term in our entire equation, isolated that variable term by getting rid of the constant that was here, and then finally make a coefficient of positive 1 for the variable. That's a good, straightforward process you can use for solving this kind of equation.